The lap shear test is one way of studying the adhesion of silicones on various materials. In order to obtain reliable results, the necessary test specimens must meet precise specifications. The silicone is applied to a thoroughly clean test plate made of the material to be tested. The next step is to bond this with a second test plate, which may be made of a different material. This involves maintaining a precisely defined distance between the test plates. Excess material is removed once the silicone, in this case ELASTOSIL N9111, has completely cured. The test specimen is then mounted into the test instrument. The lap shear test measures the force required to pull apart the two test plates in parallel until they are torn off. The maximum required force measured in this way is then divided by the bonded surface area. The result is the tensile shear strength in newtons per square millimetre or in megapascals. A key aspect of the adhesion properties of a silicone, however, is the failure pattern that results. Cohesive failure is ideal. This is the kind of failure pattern produced by ELASTOSIL N9111 or RT 744 on aluminium and PBT. By comparison, RT 705 undergoes nearly complete adhesive failure on PBT, which is generally undesirable. On both substrates, ELASTOSIL 3070/40 exhibits cohesive failure almost exclusively. Silicone grades that are not self-adhesive, such as ELASTOSIL LR 3003/30, do not usually bond to any material. If necessary, however, this grade of silicone can be made to adhere to a substrate by treating the substrate's surface with a material such as a primer. Self-adhesion is generally possible on metals with a surface oxide layer and on polar plastics such as polyamide, like the black test plate shown here. ELASTOSIL E14 primarily exhibits cohesive failure on aluminium and polyamide. Depending on the substrate, adhesion properties of silicone grades may vary considerably on different substrates and must be tested on a case-by-case basis.